Good afternoon, everyone, and good morning to those in Alaska and Hawaii. Welcome to the Basics of Site Remediation for Communities. This is Ignacio Dairit, and I'm going to be your moderator and speaker today. Before we start, I'm with the Technical Assistance to Brownfield Communities, TAB for short. TAB is a technical assistance program funded through a cooperative agreement with the U.S. EPA. It is funded, EPA has funded grants to 3 different entities, including the Center for Creative Land Recycling, Kansas State University, and New Jersey Institute of Technology. TAB providers serve as independent resources to state, regional, county, tribal, and local governments, and nonprofits attempting to clean up and reclaim brownfields. I have more info on the next slide, but in the meantime, please take a look at the map and try to figure out where you are in it. And now we have a couple of polling questions. First is, what region are you in? So we'll wait for a few more seconds before we share our results. All right, so it looks like about a quarter of you are in regions 2, 9, and 10. More than half of you are at 5, 6, 7, and 8, and about 16% of you are in regions 1, 3, and 4. And 4% of you will call up one of us, and we'll let you know where you're in. Next slide, please. So the technical assistance to brownfields is free assistance to communities. We can provide assistance on a variety of topics, and it can be tailored to the needs of your community. Whether you are in a state, tribe, or city, or nonprofit, we're glad to help you. Assistance is on a first-come, first-served basis and depends on fund availability. Lastly, there is no formal application. Just contact us. The contact information for the TAB in your region is on the last slide of this presentation. So it's on the handout, and we'll show it at the end of this webinar. Next slide. Today, we're going to go through a few introductions, and we are here to talk about remediation technologies. The roles public agencies play in dealing with site remediation, a couple of examples, and how TAB can help. And then we'll have questions at the end. We will take a couple of questions in between speakers or between topics, so feel free to put in questions on the in the chat box, and we'll get to them as we have as time allows. Our speakers almost require no introduction. We have a lot of experience among us. Elizabeth is with the New Jersey Institute of Technology, and Mark is with Kansas State University TAB. And we've been around doing TAB work for 10 years on average for all of us. And again, we're glad to help the communities. Just give us a call or any of your TAB contacts if you need any help. So before we get into the technologies, we have to figure out first why you need to know about these technologies and how local government is affected, or what the roles local government plays in these technologies. Now, unless your brownfield site has immediate environmental concerns, the reuse of a property will drive the remediation needs. This chart, created by the EPA Brownfields team and available on the Brownfields Roadmap page, is a schematic of how remediation and redevelopment play out on the site. It's intuitive, but maybe a bit complicated to follow. So we created an oversimplified version of this chart on the next slide. All right. Okay.
That looks pretty simple.
Right. So first we start with this we have started the site, And then please note that this is an oversimplification for illustration purposes only. This slide does not discuss voluntary cleanup agreements, funding, community outreach, or other steps in the remediation and redevelopment process. For most sites that we redevelop and for which we want to evaluate whether it has environmental concerns, the first step is a phase 1 or other paper document or research on the environmental history of a site. If a phase 1 reveals potential concerns on the site, such as a documented or telltale signs of past use for manufacturing or industrial purposes, then most consultants will recommend that a phase 2 be conducted. If a phase 2, which is an actual soil, groundwater, or soil vapor sampling on the site, is conducted and reveals a threat from contamination, an immediate threat, it is usually reported to environmental regulator, who may require interim measures to control an ongoing release of contaminants. As Mark and Elizabeth will note, institutional controls may be needed if contamination is left in place. And institutional controls include engineering controls such as caps and long-term monitoring, and administrative controls such as deed restrictions that may be part of a remedy. If institutional controls are not needed, then the project can be redeveloped after the site is cleaned up. If institutional controls are needed, then these will be managed as long as necessary to ensure that the environment and the public are protected from residual contamination. Now, on the same Brownfield's roadmap pages, there is a snapshot of treatment technologies. It indicates on which type of chemicals the technology is effective and which media, such as soil or groundwater. Now, that's kind of a lot of technology to cover. So we created another oversimplified chart on the next slide. Again, this is an oversimplification and for illustration purposes, but in this chart, we stress the principle of the treatment and which media they apply to. You will see that that principles are either physically removing the contamination or encapsulating it, and various treatment options on contamination that is in the soil, the groundwater, or soil vapor. Now, on this webinar, we will be addressing the technologies that are in the light blue, being excavation, capping, pump and treat, and natural attenuation. The other technologies are covered in many webinars that you can find on the web, including the CCLR webpage. So please visit it. And as a last note, which of these are considered green remediation technologies? Well, Elizabeth will go into that later. Next slide. So without much further, I will hand it over to the first technology, which is asbestos in buildings. Now, asbestos is not in our chart because it refers mostly to contamination in buildings, but you'll find that we found that most brownfield projects do involve some asbestos and lead issues. So, Mark, take it away.
Thanks, Ignacio, and welcome, everyone. As you saw on one of the earlier slides, there are numerous technologies out there. We did pick asbestos in buildings because literally over the last 5 to 10 years, we've seen such a spike in interest in asbestos remedial technologies. So it would be, we felt we would be remiss if we didn't address this, but it does have a lot of unique aspects when you're considering remediation that are different from the other technologies we're talking about. The main thing being with asbestos is quite often it's located in buildings, whereas in most of the other technologies we're talking about, the contamination is actually you're addressing a release to the environment. One of the other things we thought would be worthwhile talking about asbestos is that there can be a range of costs. It can be, that range can be great, and hopefully we're going to provide some hints and some guidance in this to help you manage costs. So a little bit about background about asbestos. It is a naturally occurring mineral, which in plain English means that it's a rock. Being a rock, it has a lot of great properties, hence it was used for many things. One of its properties that was useful was it's fireproof. It has great insulating capabilities, and it adds strength to any matrix that it's been added to. From a negative standpoint, you need to consider the health aspects of asbestos, and you can see in the picture on the left, which is an enlargement of the individual crystals, you can see that there's numerous little barbs on those crystals. And when that asbestos becomes airborne, those crystals can lodge deep in the lungs of humans and are very difficult, if not impossible, to remove. So hence it was banned numerous years ago, and that's why we're having to deal with it these days. Next slide. So where are we going to look for asbestos? When might you think that you should be looking for asbestos at your brownfield site? Definitely if the building you're dealing with was built prior to the 1980s, you probably want to do a look-see for asbestos. Quite often asbestos comes into play in historic structures. Asbestos really didn't come into use until the early 1900s. So really old historic structures, you might, if there wasn't any renovation done on it, you might not run into an asbestos issue. And lastly, dealing with old landfills, if you're might consider redeveloping old landfill, you should definitely keep asbestos in the back of your mind when you're opening up an old landfill, because asbestos quite often is in construction debris. So let's go on to the next slide. So if you do have a building and you think you might have asbestos, where might you consider looking for asbestos in that building? Short of saying everywhere, it's specifically you might be looking at wrapping around the pipes, wrapping around old furnaces, again for its insulation purposes. It's used in floor and ceiling tiles. It's been used for exterior siding, whether it's mixed into the stucco or mixed into the shingles, either roof shingles or side shingles, window caulking, and many other locations. But I do want to take a moment here to mention, because many of you might be in a position where you're engaging an environmental professional, and under brownfields you're tasked with doing a phase 1 to meet ASTM standards. So just be aware, if you're putting out an RFP and you're asking that the contractor meet ASTM standards, you are going to make it's worthwhile mentioning, adding in that they are specifically going to be tasked with doing an asbestos survey and lead-based paint if necessary. And the reason for that is asbestos and lead-based paint is not required under the ASTM standard. So let's move on to the next slide. So when does asbestos become a problem? Basically if it's in place, it's neatly wrapped, and it's not in a friable state. And in brief, friable means that the asbestos can crumble. But if the asbestos is in wrapped up and not flaking off into the air or doesn't have that capability, you probably don't need to deal with it. It's the act of disturbing the asbestos either through renovation or demolition that could either render the asbestos friable or release asbestos to the air. It's those acts of disturbance that bring about the requirement to deal with the asbestos. So under the guise of demolition, you are required, I want to say in most states, that if you are going to demolish a building or renovate it, you do need to look for asbestos. I have a kind of a good news and bad news scenario here under the demolition. If you have a situation where the building is structurally unsound, where it's unsafe to go in there and remove the asbestos, the good news is that you could use brownfield money to demolish that building, whereas brownfield money usually is only limited to removal of the asbestos. But if you have to take down the entire building, you do need to consider that the entire building would be asbestos containing. So the bad news here is that even though you can use brownfield money to take the building down, you are going to increase the volume of your friable asbestos that you need to dispose of. So you're probably going to be raising costs there. So that's the good news, bad news story. Move on to the next slide, please. So we're at the point now in asbestos remediation of considering, do we have to remove it or not to remove it? That is the question. In removal, it's costly, and as I alluded to before, it can have quite a range of costs, but removal is effective and it is a permanent solution. If you're in extremely rural locations, your transportation costs, transportation to a landfill that can accept asbestos, because not all landfills can accept it, your transportation costs might factor into your overall equation, and the number of landfills that you have access to will definitely factor in. So you might want to consider managing it in place. It is a less expensive option. It does require a management plan. These management plans don't need to be complex, but they do need to show that you're on top of things and you will not be causing a release. You're monitoring it, and you're basically on top of it. On the downside about managing it in place, if there is going to be a title transfer of the site, your buyer might not be wanting to take on the liability of managing that asbestos in perpetuity. So there is a back and forth between these removal or not to removal, or managing it in place, or doing solutions. So consider those factors when you're choosing your remedial option. Next slide. A couple special considerations I mentioned here. One is that in an asbestos remediation, you're probably not going to be working with a state brownfields program. In many states, the asbestos program is handled by the air pollution divisions in the state, and the personnel in those divisions might not be as sensitive to meeting deadlines, which quite often are necessary in brownfields projects. They might not be as receptive to cost considerations because their emphasis in their program is protection of public health and the environment, whereas your emphasis, whereas you certainly are considering protecting public health and the environment, your emphasis is more on the redevelopment side. So just, keep that in the back of your mind when you're dealing with your state program. So this second bullet, I mentioned this only half in jest because, taking the, well, a couple times I have heard this is, this asbestos site is too darn hard to deal with. Let's just get a 5-gallon can of gas and a match and take care of this. Word to the wise is do not do that. You're going to make the situation a lot worse. And last word to the wise here in asbestos remediation, again, as I alluded to before, is it's best to seek out multiple bids on an asbestos remediation. There's many ways to skin a cat in an asbestos remediation that you might realize numerous cost savings. So seek out multiple bids, work closely with your environmental professional in an asbestos remediation. So I'm going to take any questions at this point, if there are any. Type them into the chat box. If not, I will move on to the next remedial technology that I'm going to talk about, which is monitored natural attenuation. Would you just bring up that next slide and we'll see if there's any questions come in. If you do have questions, we'll be glad to answer them at the end also. So I'm going to move on to monitored natural attenuation. Some people might perceive this as a technology where it's a do-nothing technology. I do want to emphasize M&A, monitored natural attenuation, is nothing of the sort. It's an active, go back to that previous slide, please. It is an active remedial technology. It does not rely on just dilution of the contamination alone. Monitored natural attenuation, the purpose here is you're demonstrating through monitoring that the natural bugs in the subsurface are going to take care of the contamination that's present without causing a migration of the plume or impacting receptors down gradient. So now we can go on to the next slide. So a little bit more about what is monitored natural attenuation. So if you have a site where there has been an impact or there is the potential for an impact to the groundwater, then dollars to donuts, you're going to be employing a monitoring strategy, and the monitoring strategy is used to verify some or all of the following points. Basically, is there an impact to the groundwater presently, or does it look like there might be a possibility of an impact to the groundwater in the future? If you previously engaged in an excavation event, your monitoring program would be utilized to demonstrate that that excavation event was effective in removing that contamination. If you just, if you engage in active groundwater treatment and you just have a residual plume that's left, M&A is going to demonstrate that that plume is stable, it's not going to migrate, and it will clean up by itself with time. And under M&A, you're also looking at demonstrating if natural remediation is occurring. You're looking for those indicator compounds that your regulator can verify that, yes, natural remediation is occurring. Next slide. So in brief, there's probably numerous goals, but these are probably the most important from a regulator standpoint of a monitoring strategy. You want to demonstrate that it's okay, safe, and protective to leave this groundwater plume behind, and that down houses that are down gradient, drinking water wells, or surface water are protected from the plume. Hopefully the plume is stable and not migrating. You want to demonstrate that not only is the plume stable, but with time you're going to see a decrease in contaminant concentration due to either attenuation or biodegradation. So let's consider on the next slide advantages and disadvantages, and they're big here. In most cases, you could consider that comparing M&A to an active treatment technology, especially if your plume covers many, many acres, monitored natural attenuation is less expensive. If you have a contaminant plume that has recalcitrant compounds, maybe such as metals, that are not easily treated with a standard methodology, monitored natural attenuation is probably going to be your best option. On the disadvantage side, this is a big one, and again, most of us are in the brownfields arena, and uncertainty does not play well in the brownfields arena. So if you're dealing with a site and this plume becomes unstable for whatever reason, or if contaminant levels bump up, it's going to be a disadvantage to transferring title on that site. And in brief, groundwater does not move very quickly, so it's going to be a long time before you know if the plume is stable or if it's going to be. So in brief, monitored natural attenuation is not a quick process. So that concludes my discussion of two technologies. If there are questions, we'll take them on at the end. And I'm going to pass it on to Elizabeth Limbrick with New Jersey Institute of Technology.
Actually, Mark, Elizabeth, before you start, we do have a couple of questions regarding the asbestos. Why is burning asbestos, or for that matter, a building, more harmful than removing it?
Sure. So if you have a situation where the asbestos is contained in a building, but it's structurally unsound, or if it's just an old decrepit building, the act of burning the building down is going to release some of that asbestos to the air. It's going to blow around. You're going to contaminate the soil on that site. And take my word for it, cleaning up a soil on the site or dealing with a release to the air, from a liability standpoint and from a cleanup cost standpoint, it's much more expensive.
And I would add to that, if you don't remove the asbestos, chances are you don't remove other things like ballasts and other material that, if burned, creates other contaminants like dioxins. So we're waiting. No other questions are coming in. So Elizabeth, I'm going to hand over the floor to you.
All right. Thank you so much, Ignacio and Mark. The first technology I want to share with you is excavation. This is commonly referred to as dig and haul. It's a really common technique. It's exactly what it sounds like. You're digging up contaminated soil. The first step before you actually start your excavation is to identify what area is contaminated. And you do that by researching those past activities at the site, figure out what type of contaminants you have, test the soil, just get a better idea of exactly where they are and where they're not. Then you plan your excavation. And then it's actually done using really standard construction equipment like you see on this slide, backhoes and excavators. On the left, you see the backhoe digging up the soil and then loading it into a dump truck. And well, actually, I guess it's a track hoe. On the right-hand side, you see somebody measuring just how deep that excavation is. Now, the specific equipment that you use for an excavation is actually going to depend on just how large and how deep your contaminated area is. And also, you're going to have to look at whether or not you might have limited access because of buildings or some other structures that might be in the way. In general, excavations are typically about 15 feet or less, and that's due to safety concerns and just the general difficulty reaching those deeper depths. Another thing that can complicate excavations is the presence of groundwater, which you actually do see on this slide. It's very difficult to excavate once you get below the groundwater table, and you may need to then do some dewatering. So once you dig your soil out, you can collect soil samples then from the edges of your excavation, and that's just so that you can verify that you actually got all of the contamination out. We call this post-excavation sampling. You may have heard your consultant mention this. One thing I might compare it to is if you're going to the doctor to have like a skin cancer removed or something, that doctor may go in and sample those edges, the margins around where they've done the removal, and make sure that they got all the cancer. So they're making sure they have those margin samples are clean, and that's really the same thing we're doing with the post-excavation samples. So if those samples show that contamination is still there, then you can expand your excavation before you backfill it. Now, in some cases that I've worked on, we actually do what we call, this is crazy, but pre-post-ex sampling. And what we mean by that is that we collect those samples using soil borings before we get out in the field. We collect them at what we believe are going to be the edges of the excavation, and we collect them in accordance with whatever regulations might be out there. So exactly what they need to be sampled for, and at what depth and how far apart, things like that. And then see that all of those are clean. Then you go out in the field and you just make sure that your excavation extends to that area that you've already sampled. There is another way to do this, and it's called the triad method, and that's where you use real-time monitoring and sampling equipment, and you can make decisions based on the data right while you're out there in the field, and you have the excavation equipment that's already out there and mobilized. And then you determine exactly what area needs to be excavated. Once that excavation is complete, you're going to take that contaminated soil, you're going to characterize it, and you're going to make sure that it goes to the proper place. Typically, depending on the type of contamination, it might go to a landfill. In some cases, the excavated soil might be consolidated and reused, even right on your site, and placed under cap, which we're going to talk about in a little bit. But once you have that excavated area, there's a couple things that can happen. One is that it might be part of the redevelopment project that you're planning is going to have an underground garage or a basement or something like that, so you wouldn't need to backfill the excavation necessarily. Otherwise, typically, that's what you're going to do is you're going to backfill it, and you're going to backfill it with clean material. And we definitely recommend verifying that the material, this clean soil that you're putting in, is clean, and you do that by sampling that material. Next slide, please. All right, so that's how we do an excavation. But why do we do it? Well, first, there are some advantages. Number one is it's really fast. You know, you can get in there, you get the soil out, it's gone, it's permanent. So you don't have these ongoing maintenance requirements with it. It's taken care of, it's done. You have a very high probability of success. You dig it out, it's gone. It can be used in really just about any type of soil, from the finest clay to the coarsest gravel. Of course, bedrock is sort of a different story. The disadvantages are the cost. It's not particularly cheap. And even when we're dealing with what's called non-hazardous waste, which is oftentimes what you're going to have at a brownfield site, it's still, the cost can add up. It definitely is going to depend on where you are, what type of contamination you have. But in my experience, the cost for excavating, loading, transporting, and disposal, you're probably looking at about $100 a cubic yard, and that doesn't even include your soft costs like engineering and planning and the oversight, the sampling, the reporting. So if you were looking at a 1 acre site and you wanted to excavate down to 8 feet and then backfill, you could be talking about nearly $1 million. So again, it's not necessarily the cheapest thing, but it is pretty permanent. Also, if that example was using what I called non-hazardous waste. If you had a site that had what they considered to be hazardous waste, the costs really creep up from there. The next disadvantage I'd just like to point out is that you have to actually dispose of the soil. And if you're going to be taking it off-site, then you might be transporting that soil using trucks, driving through neighborhoods. So now you're increasing truck traffic and diesel exhaust fumes. You can find sometimes beneficial reuses for the excavated material, so that can help. That can make it a little bit greener, but generally it's not considered the most green of cleanups. And then also, while you're doing the excavation, you might have issues with dust and odor. So those are things to think about. There are a couple of special considerations I listed on here, which I sort of already mentioned, is that it's easiest to do when you don't have shallow groundwater, so when it's dry and you're not going too terribly deep. It's difficult when you have that high water table, and again, it really not appropriate or practical for bedrock, and it's much harder when you have the deeper contamination. Now, that said, it can be used in combination with some other techniques. A lot of times, excavation is used at brownfield sites to maybe remove what we would call hot spots or the dirtiest dirt, get that out, and then you might combine that with some of these other techniques that you're hearing about on this webinar to clean up some of those less contaminated areas. Next slide. So next up is capping, but first I have a polling question for you. Now, capping is often used at brownfield sites, especially because it is fairly simple, fast, and economical, but it does leave contamination at the site. So with that said, do we have the polling question for this? I'm not seeing it, so maybe not. Here it is. Do you think capping is an appropriate remedial strategy, yes or no? So I'm going to give you guys a minute to answer that. But as you're answering that, kind of just want to give you the idea behind capping is that it does allow you to leave contamination in place at the site.
Yes, Elizabeth, and while people are answering, we have a question that came in on the other topic.
Oh, on the soil excavation, yeah?
Yes. While doing excavation, what other precautionary measures do you have to take?
Well, it's going to depend on what your contaminants are at the site, but you might have air monitoring. You might have to keep dust down usually you do that by spraying with water. Just general kinds of concerns that happen with any kind of construction excavation. So you have to worry about the workers, falling into the excavation and being around heavy equipment and things like that. And then, as I mentioned, when you're driving the trucks through the neighborhood, there's a concern with that. Oftentimes, you might want to have a truck washing station at the entrance and exit of your site to make sure that any of the trucks that are taking the soil off your site aren't trucking soil into the streets of the neighborhood. So there's a couple of different things. So it looks like we've closed the poll, and the question was, do you think it's an appropriate remedial strategy? And 88% of you said yes. So I'd have to agree with the 88% of you, but I understand where the 12% are coming from because you are, in fact, leaving contamination at the site. But we're going to show you, hopefully, how capping can be done in a way that will be protective. Were there any other questions, Ignacio?
No.
Okay.
Go ahead.
All right. So one of the things is that a cap is really intended to isolate and prevent the spread of contamination. I would say probably the #1 thing that it does is it prevents people and wildlife from coming into contact with the contaminated material. And I'm really talking about direct contact, and I mean picture little Johnny playing baseball and he's sliding into second base. When he's sliding into second base, he's coming into direct contact with the dirt at the site. If the site is capped, he's only going to be coming into contact with that top layer of clean fill, which is part of the cap. He's not coming into contact with that contaminated soil that's underneath the cap. The other thing that it does, it should prevent wind from blowing any contaminated materials around. And depending on what type of contamination you have, you may also need a cap that prevents rain and storm water from seeping through the contaminated material and carrying contaminants either into the groundwater or transporting it into surface water like lakes and streams. So next slide. I think, you know, one of the things we have to think about when we do caps is it safe to leave contamination on site? And my answer to you would be yes, when it's properly built and maintained. And here you can see a few examples of caps at different sites. In the upper left, you see a vegetative cap, and this is actually when it was first planted, the vegetative cap. So what you actually see there, I think, is like some straw that is placed over the grass seed on top of the 2-foot soil cap at that site. On the right, you see where building foundations and asphalt and sidewalks have been used and incorporated to be part of the cap. And then down in the left, you see where a solar farm, so solar panels have been used and incorporated into a cap. Now, a cap will continue to isolate contamination as long as it doesn't erode or develop cracks or holes. It will need to be regularly inspected to make sure that it does stay in good shape. Things just like weather, plants, human activity, all of those things can damage a cap, and if it is damaged, it does need to be repaired. Next slide. This is a diagram of what I would consider probably one of your more advanced or fairly complex caps. Now, not all caps are going to have all of the layers that are shown here, but it gives you a good idea to see how that contaminated soil has been encapsulated so that people aren't coming into contact with it. The type of cap for your site is going to depend on several factors, including the types and concentrations of contaminants present, the size of your site, if you're getting a lot of rainfall, the future use of your site. Now, the construction of your cap can be as simple as placing a single layer of material lightly over lightly contaminated soil to placing, again, like several layers like what you see here on this slide. So, for instance, you might just have an asphalt cap to cover low levels of soil contamination on a property whose future use is going to be a parking lot. But a cap for a landfill is going to be something more like what you're seeing here on this slide. Next slide. So this is why consider capping. Well, there's a lot of advantages to it, and that's why this is why it's used at so many sites, because it's fast, it's a low cost, you have a really pretty high probability of success as long as you continue to monitor and maintain it, and it can be used in just about any soil. When I say that it's low cost, you know, the last thing we talked about was excavation. There you're paying to dig up the soil, you're paying to transport it off site. Here, all you have to do is really cover it. Like I said, it can be used, and with other technologies in particular, you might be using it with excavation. So again, once that dirtiest dirt is removed, capping could be used maybe on the rest of your site to prevent that direct contact with residual contamination. A lot of times it's done, it's incorporated right into your redevelopment, like you saw in that one slide that had the apartment building and the parking lot. So that was part of the cap, it was incorporated right in. It's usually one of the least expensive options, at least for those initial capital costs. Again, there are some long-term monitoring and maintenance requirements which could add up. If you're using that existing structure, such as the parking lot or a building foundation, it's going to save you a lot of money. If you're installing a cap that's like a simple cap, maybe say like a 2-foot thickness cap, I think it's probably going to run you about $100,000 an acre with clean soil. If you're looking at a cap more like that more complex one we had, you're probably looking, I would say, in the neighborhood $300,000–400,000 an acre to do something like that for probably a thicker cap like that. There's a high probability of success. It's really straightforward, easy to do, but there are some disadvantages, and I think the biggest one to me is that it's not a permanent solution. That contamination is staying on your site, and the cap is going to need to be monitored and maintained. There's going to be inspections and institutional controls like deed notices that say we have a cap on this site and you can't dig it up, as well as some reports that are going to need to be completed. And there really is oftentimes some stigma associated with leaving contamination in place. As a special consideration, I wanted to note that it's really better to use this for immobile contamination because it doesn't address you know, if you have something where the groundwater is contaminated, it's not addressing the groundwater that could migrate off-site. So if you do have conditions like that, you definitely need to use it in conjunction with something else. Before we move on to the next slide, I did want to also note, I mentioned the word institutional control. We probably have tossed around the word engineering control. And for those of you who aren't familiar with those terms, the engineering control is the actual physical thing that you would do at the site. So in this instance, it's the cap. So we've designed something and we've placed it at the site that's engineered to prevent that contact with the contamination. That's an engineering control. And institutional control is basically the paper that goes along with it. So the deed notice that says, don't dig up this cap that we have placed here on this site. So that's what I have on capping. If there are any questions, let me know as we get ready to move on to our next technology.
Yes, Elizabeth, we have a couple of questions and a comment.
Okay.
Going back to the more recent ones, why would you not implement a bottom membrane as part of a remedial cap? No concern of contaminant leaching into the clean soil and because of the death to groundwater, or groundwater death.
Why would we not incorporate? So when you're dealing with capping, a lot of times you're not digging up the soil that's in place. So yeah, you would need to know that, again, that your contaminants aren't going to cause additional problems out there, like I said. So you really want to be doing this for that immobile contamination that's out there. If you have concerns that the contaminants at the site are going to leach into the groundwater or something else like that's going to be happening, then you would need to look at some other type of technology.
Another question, for residential development, there's some concern about human contact. So how is that prevented?
So the way we manage that is a couple of different things. One is that you have the engineering control. So this is a physical cap. It's not like you're just leaving surface contamination right out there for little Johnny to go out and dig in and play. So the first thing you want to understand is that this is an actual control. Typically, it's something like 2 feet of clean fill, or it's that hardscape design like a sidewalk or asphalt, and those are pretty good at preventing people from coming into contact with it. When you're talking about the vegetative cover, I think I can understand where people think maybe that's a little more likely, and that's why, you know, the thicker the better, I would say. The thicker, the more robust it is. Probably not going to be digging down more than 2 feet. Many times I have seen caps installed where there is like a visual warning, visual barrier whether that's like an orange snow fence or something like that, something so that when people start digging, there's like, oh wait, this doesn't seem normal, what is this here? And then they realize that there's something going on and they shouldn't dig in there. And the other piece is that institutional control that goes with it. So whenever we do an engineering control, we also do an institutional control that is, like I said, it's paper. It's like a deed notice. It's something like that that tells people, by the way, this is going on here and you can't do this. And then that next piece is there is ongoing monitoring and maintenance for all of these. So if you do see a breach in the cap, then you would need to do some kind of repair to it at that point. But yeah, I can see where people have concerns about it at a residential complex, but as long as people know that it's there and it's monitored and maintained, it really is safe.
Yeah, related to that, how about plants? What's the concern with plants, and how do you actually plant when you have a cap?
Okay, so I think it gets tricky with that. I worked on sites where when we're installing the cap, we know what we're doing. We might dig out a special area for like a tree box or something like that, a tree pit, and plant the tree in there, and we'll actually put together engineering designs for how much soil needs to go in there and things like that. But you're really not supposed to be digging through a cap. So that's really the answer, is if you're going to be doing that, then you need to be going back to probably an environmental consultant and figuring out how you want to do that. The other thing you might do is raised beds, you know, so you have like a wooden box or something that you put dirt in and then plant in that, so you're not even really using the soil that's on site.
Okay, there was a question here. We're trying to figure it out, but I think it has to do with lightly contaminated soils that can be reused elsewhere. How common is that, and what are the requirements?
Well, I don't know the specific requirements. It's going to depend on where you want to reuse it, so you'd have to go to find out what that reuse is. For instance, I'm talking to you from New Jersey. In New Jersey, they have very strict standards on what they consider to be contaminated. In Pennsylvania, the standards are different. So soil that might be considered contaminated in New Jersey is considered clean in Pennsylvania. So sometimes soil is dug up in New Jersey, sampled, they determine that it's actually considered clean in Pennsylvania, and then it's brought to Pennsylvania as a beneficial reuse. I've also seen soil taken and used to be like part of asphalt that's then used for roadways. So there are different kinds of reuse that can be done. And you can also, like I said, reuse it on your own site. So you could dig up contaminated soil and then kind of consolidate it and place it all in one area, and then just put a cap over it in that specific area.
Oh, okay, and thank you. This is the last one for this topic, so we can move on, and we'll answer any other questions on this topic at the end. But the last comment relating back to the previous answer is dealing with sites that need a cap and residential. And I know this is state specific, but in what circumstances is residential actually allowed on a site that needs to be capped? And how does that relate with cleanup levels?
It is really state specific. I can tell you, like in New Jersey, as long as you can prove that the cap is preventing exposure to human health and the environment, it typically can be used at most sites. So I think that's sort of what you have to do, is make sure that you have the right kind of cap that is making sure that you're preventing that exposure to human health and the environment, and then it can be used, whether that's a residential site or an industrial site.
All right, okay. Let's proceed now to the next question, and we'll reserve other questions for the end.
Okay, thanks. So the next slide is about groundwater treatment, and this is also known as pump and treat. And again, this is a common method that you're going to see at sites where you have contaminated groundwater. It is used to remove a wide range of contaminants that are dissolved in groundwater. Typically, you're going to use this once you've already sort of gotten to the major source of your groundwater contamination. So if you had, for instance, leaking drums and contaminated soil, you might want to get to that first before you start installing your groundwater treatment system. I like to say the first thing we do is turn the spigot off, the spigot being the source of your contamination, and then we go in and we treat that remaining contamination. So like think if you're working on a gas station site and there's a leaking tank, the first thing you would want to do is pump out that tank before you move forward with trying to get your groundwater cleaned up. One other thing they do in addition to cleaning up groundwater, these pump and treat systems, is they actually also help contain the contaminated groundwater plume so that it doesn't move off-site towards lakes, streams, or water supplies. Next slide. So here we have a diagram showing the groundwater treatment process. What you see here is you see your plume, and you see that you have these extraction wells. And you see the arrows pointing into the wells. Those arrows are pointing into the wells because we are pumping water out of those wells. So it's pulling the water from the formation into those wells. Whether we're using an actual pump in the well or we're using some sort of vacuum, that's how this is actually working. Then the water goes from your extraction well into usually some sort of piping and maybe into a holding tank. And then it goes into some sort of treatment building or treatment shed where it's treated with, a wide range of things depending on what your contamination is. It could be carbon treatment, it could be an air stripper, different kinds of things. But once it's treated and it reaches the regulatory standards, then it can be reused. So, for example, after that water is treated, that effluent or the treated water, it might be injected back into the ground, or, as it's shown on here, it could be sent to a nearby stream, might even be used as irrigation water. Sometimes it's sent to your public sewer system for further treatment at the local wastewater treatment plant. Now, like I said, in addition to actually cleaning up the groundwater, the other goal here is often to just contain that plume. And again, that's done by pulling that groundwater into the wells through the pumping action. It's going to hopefully prevent it from flowing in the other direction, away from your site, away from drinking water wells or wetlands or streams or other natural resources. The next slide, please. So these are some different examples of what you might see at a site. So in the upper left-hand corner, you see some groundwater pumping wells. If a lot of sites, you'll actually see just like a manhole cover, and you won't really see much above ground where you see the pumping well. On the next one, you see that groundwater treatment building. This is a larger size groundwater treatment building. And again, you might have all kinds of different things in here from carbon. When I say carbon, we're talking about the same stuff that's in like your Brita water filter. And that's something that we use to treat groundwater. An air stripper is kind of what it sounds like, which is you're basically using air to evaporate the contaminants from the water once it gets in there. On the bottom left, you can see this is a very large indoor treatment facility. And in the bottom right, you can see what it looks like when you have an outdoor treatment facility. Next slide. So why would you consider it? Well, number one is because it cleans up groundwater contamination and it can prevent that spread of contamination. The probability of success, I would give it a medium. You're usually able to get your concentrations down, but oftentimes it's not enough to get it all the way to the regulatory standards, and you're probably going to have to combine it with something else like that monitored natural attenuation. So you'll probably run your system for maybe a period of years, and then you might turn it off and monitor the situation and see how it does in a monitored natural attenuation kind of mode, or there may be some other methods that you're going to need to employ as well. Some of the disadvantages is, boy, can it take a long time. You know, it really depends on what the contamination you have and what kind of geology you're in and all these kinds of different things. But it can take from a few years to several decades. You know, if it's a really, really bad site, you know, I mean several decades to meet those cleanup goals. And again, in some cases, you might never actually achieve them. It's going to vary from site to site. If your contaminant concentrations are high or that source hasn't been completely removed, it's going to take a long time. If it's a very large plume, it's going to take a long time. Geology and the groundwater flow is so important to this one. In order to pump, to get to that water and treat it, we first need to be able to reach it. So unfortunately, there are certain circumstances, such as in clay, that it isn't so easy to get to the groundwater. It's also very difficult to get to the contaminated water once it gets into fractured bedrock. And the harder it is to get to, the more wells that are needed, and the costs and time just go up from there. So what I want you to kind of understand from this is that you can only clean up and treat the groundwater that you can actually get to. So that's the takeaway on that one. I guess I would also mention that as part of this, there is a monitoring program that you're going to need to do, and it's usually pretty intensive monitoring. It allows you to make adjustments to the system as things change. You might have changes in your water table, especially as the seasons change, as the contamination moves, things like that. Again, you're probably not going to get all the way to clean just by using a pump and treat system. You're probably going to have to combine it with other methods. Once you get the bulk of the contamination out using the pump and treat, you might follow it with that monitored natural attenuation. And it doesn't address things like soil or sediment contamination. So it does do a good job cleaning up groundwater, but you got to look at some of the other things that are going on as well. Next slide. I really want to make sure I share with you the concept of green remediation. And this can be used no matter what kind of cleanup technology you're using. It is the practice of considering all environmental effects of your remediation and then incorporating options to minimize the environmental footprint of your cleanup and minimize the adverse impacts it might have on the needs of the current and future generations. At the same time, green remediation is really also about maximizing efficiencies. It can be done at any stage of your project. It does not have to cost more, and in some cases, it can be really easy to do. So, for instance, if you were excavating soil like we talked about earlier, you could consider using ultra-low sulfur diesel for the heavy equipment, and you could limit air emissions and greenhouse gases. In addition, you might want to have the contractors adhere to an anti-idling reduction program, right? So those are all pretty simple things you could do. When you're planning your excavation, try and find the closest disposal facility, or even better, find a beneficial reuse for that excavated material. When you're working at the site, think of other things you might do. Maybe you have an existing office building there that you could use instead of having to bring a trailer out to the site. If you're doing a cap, could you use vegetation that's native to the area? Can you use vegetation for erosion control where practical? If you're doing a pump and treat system, could you use solar or wind power for your treatment system? Maybe you could find ways that you could use different sensors that provide data back to your office rather than having a technician have to drive out to the site as often. There's lots of different ways you can do this. EPA has more resources at the link on this slide. There's just so many ways to incorporate it and make it sustainable. But now I have a polling question for you. So let's see if we can bring up that polling question, which is, would you be willing to incorporate green remediation strategies into a remediation at a site that you're working on? So please vote on that now. And as you're voting, I'd like to ask if there have been any other questions that have been submitted.
Yeah, so back to the, I think it's just excavation or the capping. Let's see. If capping isn't permanent, how can monitoring be continued indefinitely? Who is responsible to ensure it does get monitored?
It's a good question. I think the responsible party is generally the one who is going to be on the hook to make sure that that monitoring is going on. I'm sure each state probably has their own way of dealing with this. I can tell you that in the state of New Jersey, they have different permits that are required, so that that responsible party has to file, I think it's yearly, reports on that they're going out to the site, that they're inspecting it, and that they're maintaining it. And in New Jersey, they also made it so that they had to put up money, some financial assurance. I want to say something like a 20-year horizon. They had to figure out how much it would cost to monitor and maintain for a specified number of years, and then they had to actually post that financial assurance to show that they were good for it.
And that also applies to any kind of long-term monitoring, including monitoring groundwater and other inspections. Regulatory agencies typically build that into the whole remediation. So,
yeah.
So any other questions?
They can always come back.
So we have no other questions.
Okay.
So I think thank you, Elizabeth, and I think we're going to proceed. We have about 20 minutes left, and so I'm going to discuss now stakeholder roles. Why do local governments need to be aware of these remedial alternatives? Because, as both Mark and Elizabeth mentioned, these technologies are not perfect, have some impacts and some long-term implications. Some of them cost a lot, and sometimes even exceeding the value of the property, and may influence the future reuse of the site. These all play a role in the selection of the final remedy, and in many cases, the redevelopment of the project. Next slide. So here's a chart of the public agency's roles in on a redevelopment on a site, and how remediation may affect that. For instance, local government may serve as the owner, the developer, a facilitator, or the regulator. And they have very many functions. They have a planning function, an economic development function, building, environmental. There are politicians, and along with relationships with the state, the county, and federal agencies. You can see that there are overlapping and maybe sometimes, and you will realize, conflicting roles on a site, which affects the remediation technology. Next slide. As an owner-developer, a local government can acquire sites and or assemble sites, several sites for one big project, or develop the site for public or community uses, or get it ready, prepared to sell it. In most cases, local government takes the lead or assists in site assessments and remediation. Next slide. As a facilitator, in most cases, the local government does not own the brownfield site, but helps facilitate its sale or redevelopment. It can do so by helping determining the end use, providing funds for site assessments and cleanup, and redevelopment, help negotiate sale conditions, and serve as arbiters with regulators and local stakeholders. As a regulator, in many cases, the local government is a land use authority and therefore regulates land use. For tribes and in some states where where local government can assume some oversight responsibilities in partnership with regulatory agencies. They can also serve the role as the environmental regulator. Again, in some cases, local governments are called upon to assist in the implementation of institutional controls, that is, keep track of the engineering controls and make sure that these restrictions are monitored and they're aware of them, and to help manage impacts during cleanup and to manage residual contamination. Next slide. Next slide. Oh, so the implications of remediation technologies are many. Local governments are usually at the forefront of key decisions involving brownfields cleanup. One of the more questions posed by communities is, how clean is clean? In most instances, sites are not cleaned up to pristine or background levels. Most times it is economically or functionally impossible to do so. So the obvious next question is the site being cleaned up adequately to ensure the safety of the public and the people living and working on the site and the environment? Some brownfields remedial technologies take a long time and may have impacts on the surrounding neighborhood. For instance, dig and haul projects involve a lot of trucks, noise, dust, and traffic, and may take several months to years for large sites. Local governments are often asked to assist in mitigating these impacts to the community. There should be good communication between the local government and the environmental regulator. However, this is not always possible. Regulatory agencies have a narrow set of objectives, and local governments have much broader goals. The mismatch of these goals often leads to conflicts and misunderstandings that you try to avoid, and if you are aware of your role, you can head off these conflicts and come to programs and measures to ensure that your brownfields project and your remediation progresses smoothly. And I'm going to highlight this with a few examples. Next slide. So here's a map. You know, you have lots there and you have a road, and you have some contamination on one site that is migrating off-site. So if you're a local government and you I have identified, let's say, the site and perhaps this neighborhood as brownfields, what would you do? Would you potentially just assess that site on the corner where most of the contamination is? Or will you perhaps address this as an area-wide project because other sites are potentially affected by contamination on one site? Perhaps there is buildings in this neighborhood are not quite performing. Maybe many of them are vacant. And in instances where these buildings are actually occupied, you might have vapor issues and other situations which, again, lead you to think, well, is this a single site problem or is this a multiple site problem? And so, Mark and Elizabeth, if you have any other concerns, please chime in.
So, Ignacio, if we the municipality acquired the site and we knocked down the building or the structure that caused that contamination, you know, some things you can do in a situation like that is you can install an in-place remediation system and build on top of it. From a regulatory standpoint, if you're going to build on the left-hand side of the screen where the source area is, you're going to be held responsible for that stuff that's going off-site as well. If you're going to build on the right-hand side of the screen where you're in the down gradient location, you're not going to be held responsible for the contamination underneath your site, but you are going to have to take measures to protect the residents in that building that you're building on the right. So, you know, liability issues definitely are going to come into play here, and it will be state specific. So check with your state health department.
Thank you, Mark. Elizabeth? We've stumped Elizabeth. Anyway,
that's okay. Go ahead. Move on.
Go ahead, Elizabeth.
So you're going to do, at a site like this, you're probably going to be doing something like a groundwater pump and treat, but you are going to be concerned about what's going on in some of these neighboring buildings. And, you know, it's not something we really spoke about, but if there's a potential for vapors from that groundwater plume to get into these other buildings, you're going to want to investigate that. And then if you do find that that's happening, you would want to address it with something like a sub-slab depressurization system.
Yes, and thank you. And I think we're just scratching the surface here, and which leads me to the next case, the scenario. Here's a situation where you have privately owned multi-building property with some historic or potentially historic buildings and some industrial tilt-ups. There's soil and groundwater contamination that affects some buildings, and lead and asbestos in all the buildings. Now, for some of you who have been doing brownfields for a while, you're familiar with the term analysis of brownfields cleanup alternatives. And these studies will address a variety of cleanup options related to the cost and effectiveness of cleanup technologies. However, there are many other considerations that a local government would be interested in evaluating, including the land uses desired by the community, the possible uses of the buildings, timing of redevelopment, whether to get involved in the remediation or redevelopment of this site, and many other factors that stakeholders will bring up with the local government. So with that, I'm going to hand it over again to Elizabeth and Mark to chime in on what they see really very quickly as things that might prop up both in the remediation sense and in other factors that local government might get involved in.
So Ignacio, I'm going to take a guess here, and I'm looking at this fence around the building, and you said it's privately owned. It doesn't look like they're engaged in any remediation at this point. Maybe they're reluctant to engage in some remediation. Maybe this company or the owner is considering, you know, basically just sticking their head in the sand and mothballing the site rather than deal with the contamination. So as a local government, maybe your approach to this owner is cautious to begin with, but if it's a priority in your community that this area be redeveloped and that this is a catalyst site, as a local government, you might look at forming some kind of public-private partnership, nonprofits. From the owner's standpoint, they're going to be concerned that if they invite in the community, they're no longer going to be able to stick their head in the sand. Information is going to become publicly available. If the community were to take this thing over and spearhead the redevelopment, the community needs to be aware that, sure, this owner might indemnify you, but then you're going to become responsible for the cleanup. So proceed cautiously. Maybe investigate some innovative title entities that you can form up to take title to this site. Elizabeth, do you have something to add?
Yeah, I agree. I mean, I think that's the complexity, and a lot of what we do isn't so much the technical type of remedial action we might use and the scientific part of it. It's more this part of it where it's how do we get a private property owner to do a cleanup and proceed with a redevelopment at a site. And, you know, all those things you said, you know, I'm thinking the same thing, which is, you know, the public-private partnerships are really great. If the public entity were to purchase the site. Again, even though the property owner may or may not have, given them some kind of indemnification, you're liable, to do that cleanup if you haven't done your due diligence. So, that's something you kind of have to think about. And depending on what state you are in, the state rules may require that you do the cleanup anyway if you're taking on a contaminated property. And yes, oftentimes we come across private property owners who just don't want to do anything at all. They don't want to know if there's a problem at their site because they think that if they don't investigate it and they don't know about it, then nothing has to be done. But that really couldn't be further from the truth, because eventually, somewhere down the line, it's going to have to be done. And when somebody wants to purchase their property, they're going to be asking for that information to begin with.
Thank you. And I'm just going to go, we have 5 minutes left, and I'm just going to bypass the third scenario just to mention, though, that landfills, again, is a very common situation where you have to deal with interim and current uses, the productive use of it, how long they're idle. So that's a very common situation in communities where local government is often not just in the redevelopment side. They also have to deal with the remediation approaches and interim approaches. So going on to the next slide, how can TAB help? Well, as you can see, Mark and Elizabeth and our teams are very knowledgeable in a variety of issues. We have engineers, planners, and people with redevelopment experience. So we can provide that technical assistance both in urban and rural areas. We can help with identify funding and financing mechanisms, how to build partnerships. We have many workshops, and you saw a list of them earlier on. Connections to other EPA programs and connections to other federal agencies. Again, the Brownfields program does not just deal with remediation and contamination. We deal with redevelopment, and that's our goal, is because there are EPA and federal programs that assist with redevelopment of a brownfield. So here's our contact information. Please reach out to us. And if there are any other questions, well, they're coming in, and I'm just going to read them. How can you frame completing a cleanup investigation as a value-add undertaking to a reluctant property owner where the contaminants are unknown and the site sits idle?
Sure, yeah, go ahead, Elizabeth.
That's something I was, kind of touching on earlier, which is, they may think that they can get away with doing nothing right now, and maybe they can. But in the end, if they ever want to sell this property, the next person who's coming in is going to want to know about these issues. And if you can address them now, first of all, it sounds like in the case you're talking about, perhaps somebody even has some assessment grant money that might be available to them, that they're going out and, going to assess the site. So that might even be able to be done at no cost to the owner, if that's what we're talking about here. But even if it is where the owner is going to be paying to do the work, again, in the end, somebody's going to want to know. And people who are interested in purchasing properties, they're interested in certainty, and they don't like a lot of uncertainty. And the price that they would get for their property, if none of this work is done, is going to be extremely depressed from its actual value if there's any question about what might be at that site. So let me turn it over to Mark for your comments.
Yeah, in brief, I mean, this site, if it's sitting idle and abandoned, the private sector has decided not to do it. And put yourself in the shoes of the developer or the buyer of this property. Are they going to risk $5,000 to $50,000 to do a phase 1 and phase 2? If you've got the grant funding to provide that phase 1 and phase 2 at no cost to them. The value added here is that you're answering questions, you're removing uncertainty, and putting this site hopefully on an even footing with the greenfield.
And thank you, Mark and Elizabeth. And before we end, I'd like to thank both Mark and Elizabeth for great presentations. And I would read a comment here which kind of jives with what you just said, that all these scenarios we presented are assuming that the brownfield properties have specifics known of the contamination. Those experienced in brownfield redevelopment know that the unknowns are the real question, and that's why we have these brownfield grants. And initial testing will determine the extent of contamination, and further investigation can help assign liability to previous owners. Full investigation is the key to a good remediation and reuse plan. So with that, again, thank you so much, Mark and Elizabeth. Follow us all on social media, please. CCLR is on Facebook, LinkedIn, and Twitter. I'm sure NJIT and Kansas State are also have their own social media. With that, I'm going to conclude this webinar and thank everyone. And please go to, don't forget about Brownfields 2017. And if you have a site that you want technical assistance on in a very live and fun format, consider joining the Redevelopment Rodeo and visit the CCLR website to find out more about it. Again, thank you, and see you at Brownfield 2017 or the next webinar. Goodbye.